Hello again. We are continuing our discussion of inequalities by talking about compound inequalities and what that means and how we can solve them. So the first type is what's called an intersection. Okay, and that is when we see two inequalities with the word "and" between them. So both inequalities have to be true, and I'm looking for the intersection of those inequalities. Okay. You can also write it with two less than signs or two less than or equal to signs, or you can have one of each with three terms between them instead of just two. So I'll give you examples so that you can see. When we're graphing those on a number line, we're going to be looking at the part that is graphed both times. Okay, so the overlap, you might say, of those. So if I have x is greater than -4 and x is less than or equal to 3. Okay. Well, here's all the numbers that are greater than -4, and here are all the numbers that are less than or equal to 3. So if I'm looking for the overlap of those, the part that I graphed both times, the part where red and blue are both there, that's this right here. Okay, and that can be written as -4 is less than x is less than or equal to 3. Okay, so the second type is called a union. And that's when I'm using the word "or" instead. So either the first inequality is true or the second one is true. Okay, so kind of a different situation there. So when I'm graphing that, I'm looking for the part that was graphed either time. Okay, so let's look at x is less than -4 or x is greater than or equal to 3. So here's the part where x is less than -4 on the number line, and here are all the numbers that are greater than or equal to 3 on the number line. So I basically want to just combine those into one bigger graphing. Okay, and that's what that's going to look like. All right, so here's some more examples. X is greater than 1 and x is greater than 3. So here are the numbers that are greater than 1. Here are the numbers that are greater than 3. Which numbers were graphed both times? The numbers that were greater than 3. If I want x is less than 1 or x is greater than 3, then I want the numbers that were graphed either time, so make a bigger graph out of them. Okay, so that would be the green. If I want x is less than or equal to -4 or x is greater than or equal to 2, well, here are all the numbers that are less than or equal to -4. Here are all the numbers that are greater than 2. If I want the numbers that are graphed either time, that's where they are. Okay. If I want the numbers that were graphed both times, well, I don't see any overlap between the red part and the blue part, so there's actually no solution to that, and that happens sometimes. If I am graphing x is greater than -1 and x is less than or equal to 4, well, here are all the numbers that are greater than -1. Here are all the numbers that are less than or equal to 4. Which part did I graph both times? Where did the red and the blue overlap? Right here. Okay, so that's the solution when there's an "and" in between those. And then for "or," which part got graphed either time? Well, it looks like every part of the number line is covered. So that's all solutions. Okay. So sometimes you need to solve these first. You don't always get it in the solved form, x is less than, x is greater than, or whatever. You've got to solve these first. So let's say I've got -2x plus 1 is less than 7, and 3x minus 1 is less than or equal to 5. So let's solve these. The first one is -2x plus 1 is less than 7. I will add -1 to both sides so that I get -2x plus 1 minus 1 is less than 7 minus 1. The plus 1 and minus 1 will cancel, so I've got -2x less than 6. I need to divide both sides by -2, but be careful, I'm dividing by a negative number again, and that means that the inequality sign is now a greater than sign. And so my solution is x is greater than -3. On the other inequality, 3x minus 1 is less than or equal to 5. I will add 1 to both sides to get rid of the minus 1 on the left, so 3x is less than or equal to 5 plus 1, which is 6. Then I divide both sides by 3. 3 is not a negative number, so I don't need to worry about changing the sign of the inequality. The 3's will cancel on the left, and x will be less than or equal to 6 divided by 3, which is 2. So now let's graph those. The x is greater than -3 part goes right here, and the x is less than or equal to 2 part goes right here. Okay, so there's an and in between those, so I'm looking for the overlap. Which part got graphed both times? Not either time, both times. And that's right here. Okay, I can write it like that. -3 is less than x is less than or equal to 2. Okay, and here's our last example. -5x plus 2 is less than or equal to -18, or 4x plus 1 is less than -3. Okay, so let's start with the red inequality. I will subtract 2 or add -2 to both sides. And as you can see, the plus 2 and the minus 2 will cancel, so -5x is less than or equal to -20. I will divide both sides by -5. That means that that inequality sign needs to change, so -5x over -5 has to be now greater than or equal to -20 over -5. That works out to be x greater than or equal to 4. With the blue inequality, 4x plus 1 is less than -3. I will add -1 to both sides or subtract 1 from both sides. The plus 1 and the minus 1 will cancel, and I will have 4x is less than -4. Now I need to divide both sides by 4. That's not a negative number, so I don't need to worry about changing the inequality sign. It can stay the same. So cancel out the 4's on the left, and x is less than -1. All right, so here are the numbers that are greater than or equal to 4. And here are the numbers that are less than or equal to -1. And so which part was graphed either time? That part right there. So that is my graphical solution. Any number on the number line that is covered is a solution to that compound inequality. All right, so if you have any questions, please let me know, and I will see you tomorrow.